quiz we need to study homework 4 and 5?
Yeah, those are both uploaded, right?
Can you go over the removing insulation, like how now that there's like condensation occurring inside?
Yeah, read that one to me.
There's one problem on homework 4 talks about it. It says, homework 5 is the Ryan Ball. 100 mole feed stream.
Where's it going?
It just says 100 mole per hour feed stream.
Okay.
50% benzene, 50% toluene.
Okay.
Must be separated to an overhead product of 95% benzene, recovering 95% of the benzene feed also. So,
Okay, what else you know?
and then it says there and a bottoms product.
Okay.
And it says assume equimole overflow, but it says during construction, insulation is emitted from the top 3 stages. This results in heat loss, condensing 10 moles per hour on each of these stages.
Okay, do you know how many stages there are? Does it say?
No, it doesn't tell you.
It just says top 3 stages you're
Yeah,
condensing.
and it says it's saturated liquid feed.
It says alpha is equal to 2.
And yeah, well, that's the table we have.
Okay, so do you have to find the number of stages?
It says find the number of equilibrium stages to do the job at a reflux ratio of L over D equals 2. There you go.
What number is this?
This is number 5, the second part of number 5 for the homework 4.
Okay, so I have everything up there that we know.
Yeah, that's all it gave
Does
us.
it say partial condenser?
Yeah, and it said the heat loss is condensing 10 moles per hour on the stages. That's the other one.
Okay. Any ideas where to start? What's the first thing you should do?
Mass balance.
Yeah, good. So somebody was asking, how do you get information about the products? Mass balance is right off the bat. So you know 50 moles of benzene, 50%, 50 moles toluene is 100 total. And you know the purity and recovery. So remember the recovery equation. Benzene is the light one, right? I'm assuming.
Benzene is the MBC.
Recovery is XD over ZF. So you can plug things in. ZF here in this case is 50. XD is 0.95, and recovery was 0.95. So this gives you D. D is 50. Right? Right.
Yeah.
Okay, now that you know D, you can get B, because F is B plus B. So B is 50. And you can also get XB. That's ZF is XBB plus XDD. And that should be 0.05, I think, because of the symmetry.
Yeah, it should be.
All right. Total condenser or partial condenser? I forgot that.
It doesn't say.
It doesn't say, so I guess we just
Doesn't
assume
say.
partial. It would assume partial. Just
All right.
Say
I would assume total.
total, yeah, because then you have vapor. So does it say
Okay, we know the reflux ratio
yeah,
is
it does.
2.
No.
So we now know L. It's got to be 100. Because 100 over 50 is 2. We now know V, because it has to be mass balance around this, so that's 150. Because it's a saturated liquid feed, we know this is 150. And this 100 is coming down, plus this 100 plus this 100 is 200, which makes sense because 200 is 50 plus 150.
But is that not true because of the 10 moles per hour condensing in the top 3 stages? Is that where the...
Oh yeah, that's right. That has something to do with it as well. So 10, 20, 30. That's right. So this is now 230. And this is,
Does that make that 120?
yes. Which makes this 70. Something's wrong.
Or the cheap 180 on the bottom, and then you're losing 50 moles somewhere.
180 down here?
Because you're having 230 hit that boiler, 150 is coming up and 50 leaves, every 30 is sitting there.
Oh, right, right.
So you still have 150. of
Oh,
those.
okay. Yep, that was it. Thanks. Okay, that should be good. All right, now you can go about, what's that?
Well,
How did we get to 230?
Because there's 10 moles that are condensed on the top 3 stages each. So 10, 20, 30. Because there's 10 coming down from each one. So that's a total flow.
Is it, is it, is
You have
it,
100
is,
from L, 100 from P, and 30 from the top 3 plates. 230.
yeah, shouldn't that be 100 instead of 230, since it's saturated liquid?
100 there, 100 there, and then 30
The
there.
feed
Oh,
total
right.
is 100, not 50.
So maybe it'd be clear if I didn't say 10 here, I'd said 110, 120, 130. Right.
Or just 10, 10.
Huh?
Or if you just put 10, 10, 10.
Well, I want to do total flows because then I can work out the operating lines easier. So this one's got 180 coming in, but you're losing 10, so 170, 160, and then you're losing 10, 150. So that's good. All right. Can now draw the chart. We're given XD, and we're given XV. All right, what should I do now?
Is it just the same? You draw your feed line and
Yeah, okay, we'll draw that. 50-50 saturated liquid. Now what's my operating line?
it's still L over, you still do L over D or? and then-
No, so
Is it 2 over
this
3?
is,
Is it
this
2
is the
over 3?
tricky part. It's changing on the top 3 stages because of this condensation. So yeah, there's a different slope every time.
Well, the first one's 2 over 3, right? And then it changes.
How about you draw all 3?
No, the first, it's not 2 over 3 because there's 10 moles condensing here. So each stage is now like a partial condenser, if that makes sense. So you have to work out your operating line. So it's still L over D, but now your L is 110 and your D is 150.
And that changes also, right? Because the D will change.
Right. That's gonna, yeah, it's not constant anymore, so it'll change now. Your L would be 120, your D is 160.
Can you find the,
And if D changes, that means XD is gonna be different.
No, it doesn't. XD still stays the same. All that changes is the operating lines. So what happens is you have, this will be your L over D, something like this will be the operating line for the first stage. Then you'll have another operating line for your second stage, another operating line for your third stage, and then a fourth operating line.
Why do they all start at Because that's your desired product.
Yeah, that's how,
It's, yeah.
if you work out the mass balances, just see that they all have to go through that
So
point.
is it operating like the stage of the first process?
Say it again?
So each line pretty much represents the operating line for the first stage, the second stage,
Yeah, and then this one is the rest of the column where there is insulation, so there is constant.
So one stage you're gonna do L over D, which is your R is 100 over 50. Next stage is gonna be 110 over 50, and then so on.
No, you have to work them out for each one. So first one is 110 over 150, second one is 120 over 160, third is 130 over 170.
Where'd you get the 160 from?
It's 180 minus 10 minus 10. Good. Okay, so now when you step your stages, you have to make sure you're on the right operating line. So your first stage goes to the first operating line, there. Second stage has to go to the second operating line, there. Third has to go to the third operating line, there. And then there's no information about where the column,
It's fed or anything.
yeah.
No, that's-
Yeah, so I wouldn't worry too much about that. But then after that, you can go step on them.
So we don't need to consider the stripping section? Like, you have to draw stripping?
Oh, yeah.
Do you do that according to the boil-up ratio, or like, because you can't draw to any single point,
Yeah,
right?
that's true.
Well, no, it still goes to this point. It still goes to wherever the feed line intersects with the operating line of the column.
So that should theoretically, that slope be equal
2/3 over 2?
to VB plus
Yeah,
1.
it has to, because it's constrained by mass balances.
So is it 3 over 2?
I don't know what it is.
If R is 2, the bottom line should.
No, the bottom line has nothing to do with R. Bottom line is VB plus 1 over.
Okay, but it hits the slope of 2 over 3 from the top, right?
Say it again?
Like which line is this one? The one that hits here and then you draw this line to that.
This guy is the operating line for the rest of the column. This part. Well, the part that's above the feed but below the 3 stages that are condensing stuff.
We don't know how many stages.
Yeah, I think that's what the question was asking.
Oh, the last
Yeah,
one.
so for this one, it would be, the ideal would be to drop right after the 3, or like right before the 3 uninsulated parts, right? According to your picture, which I mean is drawn like.
Yeah, the picture is not to scale. I'm not sure what he was going for with the question. I think it's maybe underspecified. You'd have to have some information about where the feed is.
Because there's a question similar to it in homework set 5 also. He calls it the Ryan column.
Yeah. So if he doesn't tell you, I'd assume it's optimally located, which means as soon as you pass over the feed line, then you switch over. Which this is not to scale, by the way. I always tend to over-exaggerate, so you'd probably still have some more stages to play with in the top.
How did you find the slopes of the 4 lines?
That's so each stage has a reflux ratio. So there's an L over D for each stage, and then your reflux ratio, the slope is just R over R plus 1 still. Or more correctly, slope is L over D over L over D plus 1.
So for each column, so can you do like, for example, I know the L over D of the one where it meets in the optimal place, but can you do it for like at the 120 point where 120 moles per hour is going downward?
L is 120, D is 160, L over D is 3/4.
Okay. So D is just your V in that case or something?
Right.
Okay.
So, what if it's, oh, never mind, this is just a stupid hypothetical question. I was just gonna say, what if it says you fed on one of the uninsulated?
Yeah, so that would just change your balances. So you just adjust these numbers accordingly to what's going on.
Do we need to worry about azeotropic distillation at this
No.
point? Just stay out that?
Can you go to the angle, like, on that, it's like, subcool?
So for 2 feeds, you'll have three sections. You still have your stripping section, your rectifying section, and you'll have a third line, or a third section, which is in between the feeds, which then has its own operating line. So it looks something like this.
Yeah, I wanted to use the outside.
something like this, where this slope is still R over R plus 1. But this slope, you have to work out what the slope is there. And that'd be something similar to the L over D thing I was doing over here with the rhymes.
So, would we be able to calculate the slope for, what you name?
Yeah, yeah. Right.
Because
I know you're not gonna give it to us, but if you give us, like, mixture of liquid and vapor, how would you know the angle where it hits the?
There's an equation for that, so you'd have to know Q, which is the thermal state of the feed, and then the slope is like Q over Q minus 1 or something. They might talk about that in a there.
That line connecting to the,
Yeah.
is that?
This one?
parallel with your, snake line?
Is it what?
Is that parallel with your slope of one?
No, it doesn't have to be. That's just the operating line of the in-between section, what you would figure out with like an L over D. So because you're introducing a feed, you're messing with the operating line because you've changed the mass balances.
So how do you find your, that bottom up?
That's still VB plus 1 over VB.
So that's how you find the slope, that the line is by.
Yeah, you really only have to find 2 slopes, and then the third slope follows by just by connecting points because it has to.
So for that, for the 2 feeds, it's gonna be at 2 different points, obviously, but, so you draw the lines and optimally located, they're gonna still cross that point. So you just go down to the other feed. So like, here, let me like draw it, that's cool.
Go for it.
Like if you were to, just so I have it right in my head. Like this is like just for one. And this is like the feed line. So they meet there, and then if there's 2 feeds, one feed here, 1 feed here, and like if this one was the same, so like this one met at this point.
Same slope.
So this is the same slope as this one, and it just connects here. And then like after this one hits, right?
Right.
Okay.
There.
How would you step that line?
How'd you step the 2 feed one? It'd be the same thing. So you have to know the number of stages in your top section, the number of stages in your bottom, the number of stages in your top, your middle, and your bottom. And then whichever section you are in the column, you have to step off that line. So if there's 1 stage in the top, that's 1. Now if there's 3 in the bottom, 3 in the middle, or something like that, you'd go 1, 2, and then I'd extend this line. 3, and then 1 in the bottom again would be 1.
And if they don't tell you how many stages, then that's what you're looking for, you would just, whenever it passed that point, you would just step down.
Yeah, if you're looking for like, if you optimally.
So the optimal feeds would be whenever you cross the feed line, you're stepping up.
Right. You step over as soon as it becomes advantageous to do so.
Okay. I'm kind of confusing myself. I just want to make sure. So when you're counting the number of stages, like in that problem you did it 1 and then you went another point, isn't it like, would that still be, it's where it drops is that what stage it's
Yeah.
in?
That I usually count the spikes on or the parts where it hits the equilibrium curve is like where I count.
Okay, so
So
that's
1, 2, 3, 4, 5.
so that, but just going from the top, that second stage is on the third, like
Yeah. Well, yeah. So this point is the